Good afternoon and welcome to this special webinar, Role of AI in Smart Factories, presented by MathWorks and powered by ProMFG Media. My introduction, my name is Manish Kulkarni. I am from ProMFG Media. We are a publishing media and consulting organization focused on the industry. I thank the MathWorks team for this opportunity to host this webinar. These days, as you know, if you read the topic role of AI in smart factories, both these topics, AI and smart factories, are buzzing these days. I mean, we have seen the industry revolution, industry 4.0 revolution since past decade or so. And there are various technologies which are basically elements of smart factory. And one of them is AI, which is revolutionizing uh, everything what we do and including the manufacturing operations. And today we will explore in this webinar for the next 1 hour, you will hear from experts from MathWorks on how to apply AI to automated visual inspection across manufacturing lines and implement IoT Internet of Things powered asset health monitoring for fault diagnosis and prognosis. Uh, we will also look at the training AI applications for Industry 4.0. My request to all the audience, first of all, welcome to you all again, and please keep your questions ready. And in the Q&A box, please post those questions once it comes to your mind. And then towards the end of the webinar, we will take those questions, selected questions. We will take the experts from, request the experts from MathWorks to address those queries. So it gives me great pleasure to introduce today's technical specialist from MathWorks. First, we have Kishore, who is a PhD and industry manager for energy and industrial automation segments at MathWorks. He is based out of Singapore and plays a pivotal role in engaging with key customers and the ecosystem. His focus lies in the adoption of MATLAB and Simulink workflows. Dr. Kishore has been deeply involved in product development and system deployments within the IoT, energy, smart grid, and other applications. Welcome, Kishore. Welcome, and thanks for joining. We have one more expert, technical expert from MathWorks, who is joined us, Piyush. Piyush is a principal application engineer at MathWorks, where he collaborates with engineering teams across the sectors like automotive, aerospace, and industrial automation sectors to develop and deploy AI-powered solutions for complex system challenges. Piyush is an aeronautical engineer, and Kishore is, like me, he's an electrical engineer. Welcome, both of you. I will have a short poll question for the audience because we want to know the audience composition and their evolution in terms of adoption of AI in their journey. So I will quickly run a small poll question. I would request everyone to please vote with your answer. There are multiple choices. You have to vote with one answer. So let me just run a poll question. 2 seconds to go. I'll end the poll now. So we have very interesting responses from the audience. More than 50% say they are still exploring, and 32% are saying we are working on few active projects, and we are quite advanced in this area. Is the response of 11% of the respondents. Thank you so much for answering the poll. And with this, Piyush, we have a good feedback also from the audience in terms of their journey. So I would request Kishore to take it from me and have this wonderful presentation. So one more request, one more time for the audience to register their questions in the Q&A box. Over to you, Kishore.
Yeah. Thank you, Manish, for the introduction. Hello, everyone. Good afternoon. Welcome to AI in Smart Factories. As we saw the poll there, we saw a mix of audience still exploring the AI, and also few have identified use cases, and some have already deployed, and maybe they want to improve. So as majority of the audience are lying on exploring, just to start with basics, what to Piyush, uh, who is an AI technical expert, to start with the basics. Piyush, what exactly do we mean by AI in today's context, and why it is gaining so much traction now, and also how industrial AI is different from general purpose AI? Could you please touch on these topics?
Yeah, thanks a lot, Kishore, for the question. So I would like to, clarify where AI is different from industrial AI. So first of all, let's try to understand what is AI. So AI in general, it is a technique where we teach machines how to mimic human intelligence through different types of data. It could be a labeled data where the responses are captured along with the data, or it could be unlabeled data where the responses are not there. You just have some data captured from different sorts of machineries and all. So that is where there are two realm of data set training to these AI models. One is supervised learning on the labeled data. Then there is unsupervised learning on the unlabeled data. But at the same time, if the environment is really dynamic, that is where reinforcement learning also comes into play. So this is a general purpose AI. You could think about training different sorts of algorithms on images classification or chatbots, etc. So that is general purpose AI. Now, to your second question, Kishore, why it is gaining so much of traction these days compared to maybe a decade ago. There are several reasons. The first is nowadays we are seeing that all the heavy industrial machineries are basically attached to IoT hubs, and then basically there is a lot of data availability. There are a lot of sensors which goes on to heavy machineries. So data is not a scarcity anymore these days. Secondly, we see that there has been a lot of advancement that has been done in the semiconductor industry in terms of powering AI related chips, meaning that AI models can actually be deployed closer to the target environment in itself. And also, if you talk about training these models, you have GPUs, you have HPC server these days, so that large language models also can be trained much faster compared to traditional models as well. So that is where computational power is also an edge. Now, at the same time, in the last one decade, there has been a lot of new algorithms which have been gaining popularity. Whether you talk about anomaly detection kind of models in engineering sense, or you talk about semantic segmentation applications, so these basically require very very heavyweight AI models. And because the technology has also advanced where you can train these kind of models on your data, so these three are the primary pillars with why we are seeing a lot of traction in industrial AI use cases. Now, lastly, I would like to mention that when we mention industrial AI versus general purpose AI, it is all about setting a context. So, in terms of industries, whether we talk about aerospace, automotive, IM industry in particular, if we are having an industrial application such as predictive maintenance, or it could be in robotics, you are thinking about path planning, pick and place kind of operations which you want to automate through the robots. It could be automated driving in the automotive scenario. These days, we are having satellite images, so hyperspectral imaging. So in the engineering context, if we are thinking about different type of applications and what kind of business value can come out of these applications, then that is the industrial AI, that we are talking about. And that is where, the technology stands with respect to industrial AI, Kishore, to answer your question. Now, Kishore, I also understand that, while this is, more of a industrial AI, webinar that we are doing, and you are an industry expert, you have basically worked with hundreds of customers across the globe. So, if you can also help us understand what are certain key factors which is driving the adoption of industrial AI, these days across different industries and IEM in particular, that will be really good.
Yeah, sure, Piyush. Now, Yeah, thanks, Piyush, for highlighting how the semiconductor industry has evolved over the past decade. But I want to go a little bit before in the timeline. It's about in the late 18th century, we call Industry 1.0, where it started with like steam power and mechanization. That's the key driver. Whereas after like 40, 50 years, that's where between late 19th century to 20th century, it is mainly shifting to electricity and also the assembly lines. That's where it resulted in rise of mass production and standardized goods, and basically electric power started coming in. And for an example, Ford also started their assembly line in automotive industry. This is what like Industry 2.0. But after that, now as you clearly mentioned, Industry 3.0, that's where a little bit of bridge, where computers started coming in the mid 20th century, and also the electronics and automation started happening in the previous Industry 2.0. When I mention automation, that's where use of computers, PLCs like programmable logic controllers and some IT systems came into the picture, which made starting to the digital revolution in the factories. But now, as you said, it's more of rise of semiconductor industry, and as well as IoT, and also the big data, which transformed Industry 3.0 to Industry 4.0. And it's been like 13 years this Industry 4.0 term is coined. But now the technology is moving so fast that already there is a definition for Industry 5.0. That's where it's more of human centered AI. And the key technologies that enable this Industry 4.0 are big data analytics, AI, robotics and automation systems, augmented reality, cloud computing, bit of additive manufacturing, and robust cybersecurity frameworks.
Yeah, thanks, Kishore. I think this gives a very nice overview on what are the different technology enablers and what is really the moving piece in Industry 4.0 context, and how there are different concepts like smart factories have also, come into play. I would like to, ask you if you can elaborate more on the concept of smart factories in itself, and also since you have the experience of working with so many customers across the globe, if you can share some of the customer success stories.
Yeah, sure. So a smart factory encompasses all these technologies which I have mentioned earlier. Maybe this is how a smart factory concept looks like, where assets and the operations and optimization happen. So if you take conventional manufacturing, it is not digitalized, but over the past decade, because of the digitalization, the first step for a smart factory is the data availability and the data generation, right? That's where the industrial IoT comes into the picture, which you can see on the left hand side. So the difference between IoT and industrial IoT relies between the sensitivity and time, with respect to time, whether it is real time or not, and also the robustness, right? That's where it differs from industrial IoT with respect to the IoT. And now, once we have the data, then that's where AI starts coming into the picture, by which it becomes interconnected with industrial IoT and AI-driven optimization and cyber physical systems. It makes you to have condition monitoring and updating whenever there are some updates required. But if you see there are two levels. One is at factory level. So at factory level, it integrates technologies like condition monitoring, predictive maintenance, digital twins, and intelligent logistics, robotics. On the left hand side, you see, and AGVs or AMRs, which all of this combination together makes at a factory level automation. But sometimes the manufacturers will have multiple factories. That's where it's a global level optimization. That's where it's more of collaborative optimization, and energy management can be done by scheduling different assets based on their aging and all those capabilities. Based on their aging and then the performance matrices, right? That's how you can schedule your production.
Very nice.
So these are some of the customers we have MathWorks already worked with. If you see, the industries are like wide spectrum. For example, Atlas Copco comes from industrial equipment and food and beverage industry, oil and gas industry, manufacturing industry, renewable energy industry, robotics and automotive. This is where, and we worked on multiple applications with these customers, like for example, uh, predictive maintenance, digital twins, and automated visual inspection. If you see, like this is how each company deployed their use cases. So, for example, someone as we saw in the poll earlier, some are still exploring how AI can be deployed, right? So when we work with the customers, now this slide will give you the picture where you can start with, because for each factory, each industry, it is a little bit different what kind of application suits to them. So that's where we are highlighting the predictive maintenance, digital twins, virtual sensors, and automated visual inspections are and robotics are the main use cases where they can start their smart factory journey. And let me little bit highlight about two use cases which we have worked with the customers, like on automated visual inspection. For example, Mondi, they have implemented predictive maintenance for their manufacturing process with machine learning. So when we reached out to these customers, so first thing is their manufacturing line works for 24/7, right? So then their first question was whether your solution will run in a robust manner for 24/7 or not. That's where the first question was. Then after that, there are like already whether you can reduce the waste or not, whether machine downtime can be optimized or not. Those are the next questions, right? Those are some of the challenges. That's where they have used MATLAB to develop and deploy this monitoring and predictive maintenance algorithms and software. And it is able to predict the failures. And with this, I think it was deployed only for 8 missions in their factory, and it resulted in about 50,000 euros per year. Right? If it can be scaled for other lines as well, the savings will be more. And as you know, MATLAB Simulink offers a low-code approach, by which you can reduce the time to development to 6 months, and it can operate 24/7. And the other application, other user story is Musahi Shimizu, where they have used automated visual inspection. And this is where as you mentioned, one of the deep learning techniques in AI has been used for this. So their challenge was whether they can reduce the workload and cost for manually operated visual inspection for like 1.3 million automotive parts per month, which is very, very huge. And this is where Musahi Shimizu built a camera connection setup and pre-processed the images, created a bit of custom annotation tools, and improved the model accuracy. And as you know, MATLAB offers a wide framework to deploy the code. They have used our GPU coder product and deployed to NVIDIA, by which they can achieve anomaly detection. And what benefits they have achieved? So as you know, these smart map factories, sometimes they might not have knowledge about AI. I mean, separate departments, right? For the digital aspect. That's where we will start. We also have that consulting arm where we work with the customers and we gather their requirements, and then we deliver their solution, and from there they can take it out. So that's where it enabled seamless development workflow from image capture to embedded GPU. And they have used CAM approach, right? Class activation mapping, to estimate and visualize the defect area part. And a simple web app can be developed using our MATLAB Simulink, by which it improved the labeling efficiency.
Yeah, this was really good, and I liked your smart factories overview slide also, Kishore, where you showed different sorts of technologies which are basically getting employed when we are talking about smart factories. There is a layer for data collection, there is a layer for optimization, and you also spoke about a couple of different use cases on predictive maintenance and visual inspection. Uh, Now, what I'm trying to understand is, when there are so many different moving pieces, right, from data aggregation, all the way up to deployment of these smart utilities that we are building, what could be some of the primary challenges for organizations who are trying to start in this particular place, or even for the organizations who are already in this space? Could you throw some more light on that, please?
Yes, sure. So here I'm showing an externally available Gartner report, but however, our experience of working with the customers more or less same. So how Gartner here defined the organizations as high maturity organization and low maturity organizations. That's where high maturity organization will have a strategic and consistent processes, aligned goals within all the BUs, and then overall organization for a sustained success and morally right. Whereas low maturity organizations typically operate in a reactive approach and not a standardization across the lines, manufacturing lines, and also inefficiencies like workload, and then they cannot come to a conclusion, right? So if we see the challenges could be in multiple dimensions. Here I am highlighting only the technology and business challenges, but MathWorks as a we are a technical computing software provider. I stick to the technology aspect, but business case, that is where we work with the customers, and then whether really you are gaining those benefits or not, right? Earlier we saw how 50,000 euros can be saved per year. So the one of the like there are top four technology barriers when adapting AI in both high maturity organization and low maturity organization. So this is pretty common across the spectrum, right? So first one is the data availability. Okay, once even though you have the data, but what is about the data quality? Then second one is okay, they have identified some use case, but how to deploy it and make sure that it is working 24 by 7. That's where that is one of the use case we have discussed earlier. And sometimes this integration of AI has to coexist with respect to the existing systems, right? Like a smart factory can have robotics and can have energy management optimization and production schedule optimizations and all that, and how just this part can coexist with the others. And also the where the skill set of the engineers, right? Typically when we are working with these customers, they are very domain experts. They are the like a subject matter experts in their particular domain. But when it comes to AI, sometimes it may sound distant topic. Yeah, that is one of the key challenges which we have observed in our journey.
Yep. That was really good, Kishore, to highlight the top level challenges, right from starting out the journey on AI with low maturity accounts and also with the higher maturity accounts, where the challenge is more towards integrating AI with different application and systems.
Yeah. So Piyush, as I mentioned, these are the technology barriers, and you being the AI expert, I want to hear from you, like when these organizations start exploring AI in manufacturing, where should generally they begin the conversation? Okay, now I decided to adapt my AI. So now I'm asking you, like, how do you typically plan an end-to-end workflow, and what kind of constraints you consider from the industry, and how do you define the problem, and how you can identify the right kind of data suiting their use case? And sometimes, as I mentioned earlier, data is one of the biggest problem, whether availability or quality, how to handle it, and how the kind of digital twins can help to bridge those gaps, right? That is another one of the AI use case, and how it can make effective a factory to a smart factory. How this can you share a bit about this journey?
Yeah, this is really a great question, Kishore. And I see two different sorts of questions or different workflows in here. So the first is how to approach building AI solutions in the context of a smart factory. So basically, I would like to start with a thought that whenever at MathWorks we are thinking about integrating any kind of AI application, We try to bucketize it into these four aspects. The first is data preparation and data access. Second is AI modeling. Then third is once your AI model is developed, how do you integrate it into a larger system and do some simulation and test case scenarios. After you have seen the AI model working as a prototype in a larger system, then how do you go for deployment at a mass scale? So these are the four stages where we should be, putting our thoughts. To elaborate more on this, basically, if you're looking at data access and preparation, your data could be actually coming in from different sources. Like, for example, your data could be directly coming in from the microcontrollers, or it could be coming in from the cloud databases. The data can be in different file formats. And likewise, when we are talking about data, the real world data is not, something which you will find that it is very good data and you can start directly doing AI modeling. When we are talking about real world data, they are more often noisy. You have to prepare the data accordingly, extract some relevant features. Maybe some of you are already technology experts, so basically you can think about baking your domain expertise into the data set also. So that is all what happens in the data preparation. I will also talk about your other question, Kishore, on generating some kind of data when the data itself is not available in a while. But then the second bucket is on the AI modeling, where the right kind of AI model has to be chosen, and we should not be just biased towards selecting one particular type of model that we have come across maybe in some research papers and all. AI modeling is more of an experiment, and since multiple models training may require even larger compute resource, so that's where MATLAB as a platform also helps you with hardware accelerated training. Now, at the same time, let's say the third bucket is, when you have already trained your AI model, you should have a system where you can plug your trained AI model in a simulation environment and run some tests such that you check the reliability of these AI models, whether it is working perfectly fine in a larger system of systems context or not. And that is where you can run a lot of unit tests and other sorts of tests as well. And then finally, when you are happy with the AI model's performance, you know what is the inference rate, how fast it makes the prediction, or what kind of data is basically required. Then after doing all these checks, you can move on to the deployment phase, where MATLAB again is basically an end-to-end tool chain, whether you are talking about embedded deployment or you are talking about cloud-based deployment as well. Now, coming to your other question, Kishore, on what kind of data do we need for this, right? So, since you touched upon two application use cases, predictive maintenance and visual inspection, here I'm taking an example of an oil and gas rig. Basically, this is where you see a highlighted equipment called triplex pump. You could have data collected from different sensors on this triplex pump, like temperature, flow sensor, and the pressure sensor, etc. It depends upon the asset that we are monitoring. So the time series data can be accumulated, and then your data could come in from both healthy kind of operating environment, as well as when we have done some maintenance activities and we knew that what kind of failure has happened historically. If we go back in time, then we can also label the data for different kind of failure modes, basically. Right now, when we are talking about predictive maintenance, there are three types of scenarios. The first is, we want to understand whether my asset is operating normally or abnormally. So that is typically anomaly detection workflow for you. The second is, when you know that there is certain anomaly, then what kind of, anomaly is actually happening? What kind of failure mode is triggered? That is condition monitoring. Then the most advanced phase is when you know that a particular failure mode has started to trigger, then how much time or how many life cycles do I have left before I hit a critical failure, right? So that is where you do remaining useful life estimation modeling as well. So this is what happens on predictive maintenance. Now, since we are talking about time series data over here, that is where I would like to show you a video where this is a Symlink and Simscape environment within MathWorks toolchain. And you would see that we can create some physics-based model on the first principles, modeling. And once we have the physics-based digital twin, which we have correlated with the actual data on the healthy side, you can inject different kind of failure modes, like some valve is leaking or some cylinder is blocked, these kind of scenarios in this context. And then you can compile the model, and see that whether a particular injected failure is also shown as a failure mode or not. Now, at the same time, this is where you see when the asset was actually operating normally, then this is the green threshold region, the bounded box that you see, where the normal behavior data was actually recorded. And this data is also correlated with the healthy operational data, because after working with so many customers, we have realized that healthy operational data is something which is easiest to get, and that is where you can correlate your physics-based digital twin. Now, once you have correlated your physics-based digital twin, and then you inject different type of failure modes in the model, and then you start synthetically generating the data, then you would see that for different failure modes, the data will certainly not be in a normal operating range. So this is just to show you that when there is a scarcity of failure mode data, physics-based digital twin is the approach to generate more and more synthetic data in these scenarios. Now, the second use case, that you touched upon, Kishore, earlier was visual inspection. So just to give you a thought on how to, basically set up this entire data pipeline. First is, if there is let's say, a conveyor belt on a soft floor where you are producing a lot of different products. So that is where you can have a camera module mounted on top of it. It has to be a controlled camera environment, so it should be mounted on some fixture. And now at the same time, there should be a good lighting condition as well, because having good quality images will differentiate the performance of the machine learning and deep learning models. So in the context of semiconductor industry, again, this is some images that I'm showing on a printed circuit board production. Now, this is where with our MATLAB based tool chain, you can also interactively do image processing and also train different sorts of models to understand what kind of defects or quality inspection models could be trained. So for example, this is the defective piece where it shows that which ones are basically defective in terms of soldering and all. So this is to show you a picture on visual inspection, how do you set up the complete data pipeline. Now, I would like to show you one example where this thing was deployed live. So here is an example of a hex nut. You see left image is the raw image. Right one is where AI model is actually classifying whether a part is doing okay or not okay, whether it is okay or not good. And then at the same time, you could also see that there is a heat map, that where are the pixels where AI model is focusing, right? So when the part is not good, it is highlighting where the defect is also observed. And when we place a good part back again, that is where you will see that the heat map is more distributed, meaning that the AI model is not able to locate the fault in this case, and that is why it is classifying a part to be good. So that is where this is more on the explainable AI side, that we can understand the behavior of these AI models through the right modeling practices as well. Yeah, that's about it, Kishore.
Oh, so one more thing is when you are working with this customers, you will come across sometimes they might be using a Python, right? And how in your 4-step workflow, how it can be integrated, and whether MATLAB and Simulink can work complement each other or not, and how does MATLAB accelerate the adoption of industry AI from design to deployment if someone is using already the Python?
All right. Yeah. So I would like to take your second question first, that, how MATLAB can accelerate this whole, journey. So first of all, MATLAB is a low code environment. Basically, we understood while working with different industries and engineering teams across the globe, we understand where are the pain points. So for example, pain point could be just preparing the data for AI modeling, and that is where a lot of surveys have been done by Gartner and Forbes and other magazines as well. And you would see that 80% of an actual engineering team's actually time goes into data preparation itself. So that's where we have got a lot of automated and interactive applications in MATLAB, where an engineering team doesn't have to write a lot of code. They can do things interactively. So I will also showcase some of the examples in the in a few minutes. But then the other thing is when it comes to testing the performance of your models in a larger system, that is where we have mix of both physics-based modeling as well as data-driven modeling, such that you can really test your algorithm in a production scale kind of scenario before actually taking it for deployment. And lastly, as I spoke earlier in the four bucket workflow, your code generation capabilities are also automated with MATLAB toolchain, meaning that while you are programming in MATLAB or while you are building solutions in MATLAB, when you want to take it for production, you will need the right code to be generated. It could be C++ code for target agnostic deployment, or it could be target specific code generation like CUDA code or PLC code, etc. So in those cases, MATLAB also has workflows to do auto code generation without you explicitly writing any line of code. And we also are very tightly integrated with a lot of cloud providers, and we have the right practices in place such that your solutions can be taken to the cloud-based environment and also desktop-based environment as well. So with that context, let me show you some of the examples on how these apps look. So this is an example of a signal analyzer app where you can bring in a time series data, you can do frequency domain analysis, you can do time frequency domain analysis, and then you can also automatically label this data in something like, signal labeler application. Now, the animation that you would just see playing, this is a diagnostic feature designer app. Let's say we import a time series data, then you can compute 80 different features. So it is really breaking down the behavioral aspects of the signal in itself, where you can extract time domain features like median, mean, kurtosis, crest factor, etc. over a rolling window. Now, at the same time, in the frequency domain, also you can compute features like what are my fundamental frequencies, what are the corresponding amplitudes, what is the band power of the signal, etc. Lot of features we have added on the rotating machinery side as well in this app. And then you can also rank these newly generated features which were not part of my original data within this app, because you don't want to take hundreds of features for AI modeling. You want some of the features which are really impacting your analysis at the end of the day. So that is where you can rank these features as well using this app. Now, this was on the time series modeling. Now, on the images part also, we have images and videos part also, we have image labeler application and ground truth labeler application, where you can interactively label the data, as you would see in some of the animations on the left-hand side. At the same time, I would like to mention that MATLAB's image processing and computer vision module helps you generate some interactive code as well through another set of applications. And once you have generated the image processing code, the same code can be then automated to label the data much, much faster without you manually labeling the data image by image, right? So what I'm trying to say is it really enhances your productivity when you are trying to prepare your data in MATLAB toolchain compared to the work that you might be doing in Python or any other third-party tool for that matter. So here is a quick example of, again, a semiconductor example that I'm taking over here. So here what I'm showing you is a color thresholder application where if you are basically denoising the image, you are creating a mask out of it to understand which are the poor quality portions where some holes are actually missing, or some holes are there in the printed circuit board. So we are doing all of this operation interactively. You could see that once the mask is generated, you are able to highlight different areas of interest in our image. And we can also select only the regions which are more circular in this case, and also generate MATLAB based function out of it. So at the same time, I would like to just highlight that MATLAB is an interactive tool. At the same time, you can generate the code which is being used by these apps behind the scenes. So it is a complete white box operation which helps you accelerate your development time, but at the same time, it is also doing the complete knowledge transfer on how things are building at the back end, right? Yeah. So also on the AI modeling side, again, there are a lot of applications. We also have features like automated machine learning, etc. in MATLAB. And we also have experiment manager app, which lets you manage different experiments between training different machine learning models and fine tune different machine learning and deep learning models as well. Uh, Now, this is a very quick example that I would like to show you in a minute, where I am loading a feature set in MATLAB in an app called Classification Learner. And here you can select which is your system response, what kind of data you want to hold out for testing the performance of the model later, and what kind of data you want to expose for model training. And then once you have imported the data, you can also select between different number of models over here. You can see at one click, I can import almost 30 different models and start training these machine learning models in parallel, depending upon how many cores you have got available with you. So parallel computing is also there, meaning parallel model training is enabled. After the models have been trained, I would like to show you that this is what we call as a confusion matrix, where the x-axis is where the model is predicting a particular type of failure or particular type of response in this case. Y-axis is what actually was the response. So if this matrix is diagonal heavy, means that training has gone really well. So that is where it can also highlight which model gave you a better performance compared to other. Now, like I said earlier, this app can also generate the complete source code, which was basically used to train these models at the back end. Okay. Same time, I would like to highlight that MATLAB also has launched something called as a Copilot, which is a local AI chat assistance within the MATLAB environment in itself, where you can generate new code, where you can ask it to explain some of the existing code, you can generate comments, you can generate test cases, etc. So it's a local AI chat assistant within the MATLAB environment. Although we say that MATLAB is a low-code tool, we also have this Copilot where the code can also be generated by just using some of the prompts. Now, coming to your second question, Kishore, where you asked about lot of people in the industry are using Python. So what we are doing about it and how MATLAB can coexist with Python. So first of all, we are maintaining a great repository on GitHub where a lot of state-of-the-art trained deep learning models are there. You can check it out on GitHub. So, I mean, you can Google MATLAB Deep Learning Model Hub, and it will point you to the right GitHub repository. There are n number of models over here. Now, at the same time, if you are working in Python environment, where you are working in some of the popular libraries like PyTorch, TensorFlow, Keras, etc., you can still bring your models in MATLAB directly. We have the right importer object and exporter objects also for the same. Now, if your model is actually developed in a different library, that is where you can also generate the model into Open Neural Networks Exchange format, ONNX format, and that way the model can be imported in MATLAB and vice versa as well. Yeah. So at the same time, we have had multiple customer stories where, the teams have been interested in deploying these models also on embedded targets. That's where we have libraries for model compression as well. Yeah. So that's a long answer to your question, Kishore.
Wow, very long answer. Thank you, Piyush, for sharing the entire that four-step workflow and also highlighting how the domain experts with a lower skill of AI can still adapt AI in their use cases, in their work, right, through low-code approach. And good to see that MATLAB also has MATLAB Copilot, by which if someone even just starting new to the MATLAB, it can, yeah, simplify the process, right? To simplify the learning curve. And lastly, you mentioned about the MATLAB plus Python. That's where good to know that MATLAB and Python can complement each other. And as you know, right, with the advent of Gen AI approaches, programming language will not matter anymore in the future years. That's what I believe. So that's where now the AI model can be developed in any language, right? So when you have shown this four-step workflow of the first one is data prep, second one is AI model, and third one you have tested it and simulated it perfectly. Now once you have be ready with the AI model, how you take it to the production, and how you ensure that it remains reliable and scalable for real world factory environment, right? Because sometimes we will come across different kinds of targets that are needed based on the time granularity or time sensitivity that is needed. For example, maybe faults, we have to act in the microseconds. But for example, if someone is working on predictive maintenance, the data granularity could be different. So how different targets can be programmed, and where these AI models can be deployed. And finally, what advice or resources you have, so that you can share with someone to just get started with this industrial AI.
Yeah, thanks, Kishore. So to touch upon this last piece on the deployment step in that four bucket workflow that I started out with, you can think about two realms of deployment. The first is the embedded target on the left-hand side in this schematic, and then the right-hand side shows the cloud-based environment really. So basically, we have Coder family of products, which does automated code generation between MATLAB language and the target specific language. So you can take your code really to your CPU, GPU, PLC, and FPGA kind of environments without you manually writing any line of code. Now, at the same time, something which is not highlighted in this slide but really important is MATLAB code generation is byte traceable, meaning that whatever logic you have written in MATLAB code, it traces really well to what is the piece of code in your other language, something like C, C++. And that is where you can understand how your entire code has been taken into the target language. Now coming to the right hand side, where you want to deploy your code maybe on the cloud infrastructure or even at a desktop infrastructure, MATLAB provides you capabilities to build dashboards where you can have very nice interactive visuals. At the same time, if you want to package just the analytics and host it on some on-premise server of your own, or maybe you want to use something in the AWS and Azure kind of environment, that is where we have the right protocols using which you can package your algorithm and deploy it on a server which is running 24/7. You can create microservices, Docker container images, all these things. You can integrate your code to read from different kind of databases within the cloud infrastructure itself. So this is kind of end-to-end deployment where we have tight integration with different vendors on the embedded side as well as on the cloud providers. Now, this is a quick example of that pump, the example that I was taking for the predictive maintenance. This is a dashboard which is deployed as a web application. And here you can see between 10 different pumps, which ones are needing attention, when was the last service due at an operational level. You can also drill down into each selective pump and then see if it is seeing any kind of failure, what are the raw sensor analytics at a periodic rate, and then what is the remaining useful life. If something is failing, then which particular module is failing. And this was done for one of our customer use cases. So this is a real world data, on which we have built this kind of a dashboard. So this is just showing you a glimpse that this entire dashboard was also built in MATLAB. The backend deep learning model, which is also predicting different type of failure modes and all these things are also trained in MATLAB, and the deployment is also on the MATLAB based web app server for going on to on-premise deployment. Now, your other question was how can somebody get started in this particular space. So first of all, just to recap as a summary, MATLAB as a tool chain gives you a head start in accelerating the whole development cycle. I see it this 4-bucket workflow where I also saw different interactive and automated applications using which you can accelerate this journey. Now, to start with, we have resources, not only resources and training modules and reference materials, not only in the AI space, but we have a good set of materials for you to go through, whether it is model-based design, whether it is system engineering, model-based system engineering kind of workflows, or if you would like to integrate your solutions in a continuous integration, continuous deployment framework, CI/CD framework, or you want to build something around DevOps, we have all the reference materials and training courses also through MathWorks, which can seriously help you upskill your game. I would like to point out that, this is where we have collated necessary resources. This QR should be accessible. I would also request the organizers to maybe paste a link to the resources page, which participants can actually go through, which will also give you access to this whole presentation material that we are sharing. And at the same time, you can see a lot of other resources on our training modules, some of the quick links on going through different TikTok series, etc. will all be part of this particular resource page. I think the necessary link has been shared. I'll just take last 1 minute to brief you over what it will consist of. So, MathWorks also has different on-ramp courses which are free of cost to get you familiarized with how to use our toolchain on building AI-based solutions. But at the same time, if you are interested in generating synthetic data and all, we have on-ramp courses on model-based design framework as well. Now, along with that, we provide different services. Like, for example, we have dedicated training team which understands your request, the number of headcount in your team who are interested in upscaling their game on something like AI or model-based design framework, etc. So we can deliver custom trainings to you. And now we also have a consulting team which can take in your project. Let's say you decide that we want to build something, but we are not there yet. Can MathWorks help us build the complete end-to-end solution? So that is where our consulting team can also take those kind of projects. At the same time, you also have the necessary technical support always available from MathWorks team, where you can get in touch with our experts and understand how a particular solution has to be approached. So which are technically done through some technical engagements that we do, which are not chargeable, but it is just more of a free technical support that you get with MathWorks. Yeah. So with that, I would like to end this. I think we will have another poll. Yeah.
Thank you so much. Thank you, Kishore, Dr. Kishore and Piyush. It was a wonderful presentation. There are some questions in the Q&A box. We will take a couple of them. But before that, I would like to announce two things. We'll run a poll quickly now. And there is a surprise for you all, for the audience. There is a lucky draw. So there will be a lucky draw winners announced at the towards the end. So please stay back. I will just run a poll, and then we will have some questions, if time permits, from the audience. So this poll question is on your screen. So I would allow another 20 odd seconds for you to register your responses here, and stay back for the lucky draw winner names. I'll wait for 10 seconds more. Please have your responses registered here on this poll. 5 seconds to go. 4, 3, 2, 1. I will end the poll now. Thank you so much for your responses. So we have about a few minutes of time left, and I must compliment Dr. Kishore and Piyush for an insightful presentation. I will take some questions. There are a couple of questions on using the AI libraries in LabVIEW. Could you please answer this?
Yep. So the AI libraries in LabVIEW environment, if you want to use, you can compile some of the functions from MATLAB and generate the library for LabVIEW as well. We support DLL generation as well, which can be integrated in any software for that matter.
Okay, great. There is another question about what all components are required for MATLAB to do all that was presented today.
Okay, so MATLAB, is more of a warehouse where a lot of different tools are there. We have got almost 150 different toolboxes, I would say. With respect to data-driven workflows, there are hardly 9 to 10 toolboxes. For data acquisition, we have a couple of toolboxes like, data acquisition toolbox in itself, instrument control toolbox and all. Similarly, for machine learning, deep learning, there is a separate toolbox. Predictive maintenance is a toolbox. So I would say that, once you start exploring our resources page that we shared, it will also guide you to some of the reference materials where the different toolboxes will be also highlighted pertaining to your application. So there is not a generic answer, but also coming to the deployment part, it really matters where you are trying to take your solution to. And that is where we have coder products, compiler products. So, but in complete data-driven workflow that we shared, hardly 8 to 10 toolboxes will be used.
Okay. And there is one question about since you mentioned about resources, what all different brands or makes of PLCs and DCS uh, could be connected or could be integrated?
Yeah, so while we do not give the direct answer to what kind of ports and these things you should be working with, but we have worked with Beckhoff PLC in the past, and they have also shown our visual inspection kind of solution to the audience. So that is something which as a resource material you can also find online. Beckhoff PLC we have good integration. But at the same time, since we have PLC coder, so PLC code generation should be something which is supported out of the box.
Nice. There is one question very interesting. What steps should companies take now to future-proof their manufacturing processes with AI? It's a very interesting question.
Okay, sir, you want to take that?
Yes. So as I explained earlier, smart factory not only involves AI, right? It requires robotics, autonomous systems to be deployed. And when we are working, the major constraint is the budget. I mean, how you can allocate some budget and finding the right use case that is very suitable for them, by which, first of all, they can gain some ROI from them, right? And second thing is, once you have the some typically in this area, the manufacturers works with the turnkey solution providers. They don't typically develop in-house these solutions because this is like, as I said earlier, bit a distant topic, right? That's where they rely on turnkey solutions. But
Okay, nice.
once they see the advantages, they understand that, okay, these things are available, then they can maybe start their own digital transformation journey, and they can add piece by piece for this making it a smart factory.
Making it a smart factory. One final question, audience question, very
Yeah.
interesting. A quick answer to this is, are there any specific KPIs or metrics that best capture AI's impact on productivity and quality? A quick
Yes.
answer, then, because I have to
So
announce the winners of the lucky draw as well. Yeah.
so today I have just shown the two user stories. So KPIs and whatever be the metrics for this AI, right? Typically depends on the use case what you are trying to develop. For example, let's say you are developing visual inspection, then of course it's a human labor cost. Sometimes human can give the same output at a lesser price, then human output is better, right, from economic point of view. And let's say if we take predictive maintenance typically at least the asset should be like greater than $7 million, then only having this kind of predictive maintenance solution is better, because it is not only about developing and also maintaining it, which requires bit of skill set and then the long-term planning.
Thank you so much, Dr. Kishore and Piyush. Thank you for answering these questions. There are some more questions which remain unanswered from the audience. So, audience, you have the contact details of both Piyush
Yes.
and Dr. Kishore. You can get in touch, and we can take these questions offline. Thank you so much for your all the insights shared by Dr. Kishore and Piyush, and thank you to the audience for being so patient and listening and asking very interesting questions. And as I promised you, there are lucky draw winners, and there are names which I'll announce, and they will get the lucky draw prize in their email box. So please keep a check there. Chetan Joshi from Tata Chemicals. The second winner is Dipti Pardesi from JSW Steel. The third winner is Chetan Pethe from Hitachi Energy. Rahul Dhadke from Gold Medal. And final winner is Nagendra Singh from Welspun. Congratulations to all of you. And I again thank the MathWorks team for giving us this opportunity to Pro Energy Media. Please stay tuned for the crisp summary of today's proceedings on our LinkedIn page.